Okay, friends. How are you starting to feel about these factoring? Some of you are coming and getting help, and I think some of you are feeling a little bit better about it. Some of you might not be getting any help, and you might have it down, and some of you might not get any help, and you're just upside down in it. So, let's see. For this week, we have quiz on Thursday. Okay. So today's Tuesday, I believe.
Yes, it is Tuesday.
So today's going to be more about factoring some special cases, but I want to see what kind of questions we had on the homework. What page were we on?
35 and 36.
Works for me. So what kind of questions did you come across?
Nine.
Number 9?
Number 9.
Problem number 9. We got x squared minus x minus 12. Okay? So some of you might see this the quick method, some of you might not. So let's just do the original. I have a lead coefficient of 1. Multiply, so I get negative 12. Good? Good so far?
Yeah.
Some of you have earbuds in. I'd strongly encourage you to please remove them. So then, what does this tell me about the signs of my two binomials for the answer? The what?
Negative?
One negative,
One negative.
1 negative, 1 positive. Okay? So I got 1 and 12, 2 and 6, and 3 and 4. Which of those, 1 being negative, 1 being positive, would add up to be that negative 1? What do you think? 3 and 4?
4.
Which one has to be negative?
Negative 4.
Good. Negative and positive. So x squared plus 3x minus 4x minus 12. Again, I could have had minus 4x here, positive 3x here. It's still going to work out the same. Let's underline those. Underline those. So what do we get in common here?
X.
And I have x plus 3 left over. This sign always comes down. What do I have in common here?
2.
4.
4. So it's a negative 4 factoring out, so both of those signs there are going to change. Answer is?
X plus 3, x negative 4.
Plus 3x minus 4.
Can
Cool.
you do 12, please?
Uh-huh. I'm even done with 9. Jumping like that, okay. Ooh, 12's a good one. Ready to move on to that? Number 12. All right, 12. 12x squared plus 17x plus 6. First thing I would do if I saw a problem this big, I would be curious, just because I'm going to have to multiply 6 and 12 together, so that gets a bigger number. Do I have a greatest common factor other than 1 on all 3 terms? I have 12, 17, and 6. Is there a number that goes into 12, 17, and 6 evenly? 3 don't go into 17. 2 isn't going to work. Do we have a greatest common factor, yes or no?
No.
No. Okay. So I guess we're subjected to multiplying 6 times 12. And what is 6 times 12?
72.
72?
Yeah.
Yeah, cool. I like it. Good job. What do you know about your signs of your problem? Both positive, both negative, one of each.
Positive.
They're both positive. Every sign there is positive, so I should say this. Factors of 72, I think we can get rid of 1 and 72. 2 and 36, I don't know. 3 and 24. Hey, that's getting kind of closer. 6 and 12. Ooh, 6 and 12, I had those. 18. 7.
8 and 9.
8, 9.
Is that 72?
8 times 9 is 72, is that right?
I don't know.
Because I know that 8 plus 9 is 17, so it'd be really awesome if 8 times 9 was 72. What do you think? Is it or not? Yeah. It is. Cool. Oh, this is going to be a good problem. All right. Everything was positive, we said, right? So I got 12x squared plus 8x plus 9x plus 6. What do I have in common here?
4x.
4x. Good. So that's 3x plus 2. Agree?
Wait, I have a question about that part.
Talk to me.
Okay, so basically, when you're saying like, what do we, like, you underline 12 and 8x, and you're trying to find out what?
What I have in common between those two and those two only.
So does that mean like, what's the biggest number that goes in both of those?
Mm-hmm. And the most amount of x's or y's or whatever I can factor out.
Okay.
So then this second sign here has to be here. What do I have in common between these? 3. Answer? 3x plus 2, 4x plus 3. Done. That's it. Over and done with. What else did you come across? Doing okay? Number 7? Okay. Number 7. Oh, okay. 2. Thanks for asking on that one. That's that, right? Yes, plus 5. Okay. I have 2 of those. That okay so far? I can do this. That okay? And then like terms, we got 2x squared minus 4x, because of those, plus 7. Done.
I thought you'd have to do 2 parentheses x minus 1 and then do another 2 parentheses x minus 1 plus 5.
Nope, because the only thing I have 2 of is the x minus 1s.
Okay.
I don't have 2 of the 2's as well. Cool. You got all done, Tom?
Yeah.
Sweet. Thanks, man. Should get that grade before we have class, okay?
Alright,
Anything else? We good? Happy? All right, if you would, make sure your name is on that and pass it on forward, please.
I feel like you should.
I don't have to, man. The last name is Stir.
I think I'm just gonna wear like cowboy boots, cowboy hat, like a jean skirt or something.
Cool.
Are you gonna dress like a cowboy yet? I'll do it. I don't know, I have an aerobics first period, so
Oh.
it's like hard because I have to go to workout. Just change. I know, it's already, I already do that.
All right.
I know that. I'll see.
Let's start this. So we're starting out talking about, we have one particular special case. There are 2 special cases they often hit in Algebra 1. But we were talking this morning, we don't really think it's that important to hit the second one. The one that's ideal is called the difference of 2 squares. And we're going to see that in a little bit. But one of the special cases is just called difference of 2 squares. which just means I'm subtracting two perfect squares. Like 9 is a perfect square. X squared is a perfect square. 9x squared is a perfect square. Okay? So we're going to start seeing this in a moment. Well, let's warm up with this. Foil these for me, please. Those are on your paper, right?
Yeah.
And so once you get done with them, double check that your answer matches mine, or I can do my math. Those are my two answers. Check them when you're done. See how you did. Homework. Yeah, that should be number 5. Yep, that's page 5. Make sure you wave to camera. There you go.
Boys.
So sometimes when they're together, it just means we multiply them together. Agree? This is not new. This is something that we've been working with quite a bit. Can I move on to the next slide? Is there any questions about what we did up there? Good, everybody? Solid, happy? Yay. Okay. Sophia, this one's directed towards you. How many x plus 3s do I have up there?
2.
How many 5s do I have up there?
1.
Okay. Do you see that? So then I have this. So there's a number of ways we could do this. I could FOIL these two together and then distribute everything by 5. Or I could do this. And it's going to give you the same exact answer. Notice I just distributed the 5 over one of the sets of parentheses. Agree? Now let's go ahead and FOIL that. So 5x and x is 5x squared. 5x and 3 is 15x plus 15x plus 45. Like terms are 15x and 15x. So far we just talked about just multiplying them back together. Just straightforward foiling, double distributing first, then foiling. I mean, there's all kinds of stuff. And these are all definitely things that come Thursday we will see on the quiz. And move on. Happy? Okay. Are we factoring any of these, or are we just multiplying them all out?
Probably.
Just multiplying them out. This times this, that's what? 7x squared plus 14x. Done? Right?
Yeah.
Okay. How many x plus 1s do I have right there?
2.
2. That's kind of a nasty looking one. I mean, there's all kinds of x's all over the place. So I could distribute the 8x over first, or I could just multiply those together. So let me just multiply those together right now. So that'd be x squared plus 1x plus 1x. That's 2x plus 1 plus 4x. I get up there, x. Distribute this over here and here and here. So what is 8x times 8 or times x squared?
3x.
Good. Ax to the third. Plus 16x squared plus 8x plus that last 4x. I do have like terms with 8x and 4x, correct?
I have a question.
Yeah.
Okay, so I did it the other way.
Uh-huh.
And it says 8x times. Wait, hold up. It says 8x squared times 1. How would I do that?
Oh, so you want this times this? So that gives you 8x squared, and that times that gives you 8x. Then you would take 8x squared plus 8x and multiply it with this, FOIL it. And it should come out the exact same answer.
Well, like, if I'm ever multiplying 8x squared times just 1? Because, like, what would it be? 8? Would it
8x
be
times 1 is just 8x, yeah.
But what if it's 8x squared times 1?
8x squared times 1? Still 8x squared.
So, oh, okay.
So whatever times 1 is whatever.
Okay.
Right? So smiley face times 1, smiley face. Okay. And then how many x minus 3's do I have on this one? 2. So let's just do this just to show you we can do that as well. So that's going to give me 6x squared minus 18x times x minus 3. Got to move it down because I ran out of room. Then multiply this out. Oh, this one's going to work out nicely. That's squared. Cool, cool. All right. And plus 54x. Here's my only like term, so I got 6x to the third minus 36x squared plus 54x. So just review, just kind of things we've seen over and over. Agree? May I move on?
Yes, sir.
Okay. So these are going to be starting to get into the difference of two squares. So take a look at x squared plus 0x minus 4 and take a look at x minus 4. So just looking at these two.
I thought 0x wasn't a thing.
0 times x is just 0, right?
So no x?
So no x. So those are the exact same thing written two different ways. Okay? So let's do this. Let's do this our way. So I'm going to multiply by negative 4. So we get negative 4. So I know I have one positive, one negative. What factors of negative 4 add up to 0?
0.
What factors of negative 4 add up to 0?
4.
2 and 2. One being positive, one being negative. Okay? One's positive, one's negative. If I add 2 to negative 2, I get 0. If I multiply 2 and negative 2, I get negative 4. So this all of a sudden comes down to x plus 2, x minus 2. We don't even have to go do it our longer way. So if that is the case here, then this is the case here. Don't those two binomials look the same, except I have one sign off a little bit? I have one positive, one negative. They're actually called conjugates of each other, not conjugates, like in French and other languages with verbs. Conjugates are binomials that are the same exact binomial off by one sign. Anyone want to take a shot at what the bottom problem factor would be?
I'll try.
Go for it.
You the one on the right?
They're both the same problem. It's your choice.
Oh, they are?
Uh-huh.
Is it? I don't know.
Okay. Yes. And? Yeah. Very good. So those are both the exact same problem. They're conjugates of each other. So these are called the difference of two squares. So can we have it listed with a 0x in there? Sure. Is it not really? It's not really proper math, but it's not incorrect math. It's just 0 times a variable is just 0, and you're allowed to have that. Difference of two squares. So let's take this one step further. Everyone feel okay with this?
Yeah.
This one's a little different. We'll come back to those. All right. Is there a greatest common factor between 6x squared plus 4x? And I believe that's a 10. If not, I'm going to make it a 10. Is that okay? What do I have in common? 2. Agree? So if I factor 2 out, I get 3x squared plus 2x minus 5. Is that okay? Be sure the GCF is part of the answer. Okay. I'm going to bring this 2 straight down. That'll be where I put my answer. What should I do next?
Factor the x's.
Yeah, let's see if we can factor this middle section out. Let's see if this right here will break down. Okay? So, what do I get when I multiply that back?
15x.
Careful. Negative 15. If it's negative 15, what do you know about both signs? One has to be positive, one has to be negative. So I want to know the factors of 15, one positive, one negative, that add up to 2. 5 and 3? Which one's positive?
Either one?
No.
Oh,
The
wait, no.
5 is positive, the 3 is negative. If that happens, I get a positive 2. If I flip-flop the signs, I would get a negative 2, okay? All right. Let's plug them in. So I get 3x squared plus 5x minus 3x minus 5. And again, I could have had the plus 5x here and the minus 3 here, and it would have worked. What do I have in common here?
X.
X, very good. This sign always comes down. I'm factoring a negative 1 out of both of those. If I factor negative 1 out, it just changes both sides. So 2 times 3x plus 5, x minus 1. There's my answer. Notice, if you bring that GCF down to the end, you won't forget it. A lot of times when I see this kind of problem worked out, I see the student gets to this step, they don't carry it down, and then they get down there and they have that for their answer, and it's a 3-point problem. I take 1 point off because you didn't have the GCF listed. So as soon as you realize you have a GCF, just arrow it down to where you're going to put your answer. Okay, it's not wrong to do that. Some people are like, oh, it's sloppy. Well, get the right answer. Who cares? Can I move on?
Wait, just 1 second.
Good? Happy? All right. This one says, hey, 30x squared minus 44x minus 10. Greatest common factor? 2. I like it.
Am I supposed to think of a greatest common factor in my head? Or is it okay if I like don't know it?
Well, if they're even, you know 2 is going to work as a minimum, right?
Yeah.
And then if they're still even, then 2 again, which then means it would have been a 4.
Okay.
So just play with it. And I'd always have like a small calculator out, just like if you're like dividing everything by 7 and you're not sure, go 44 divided by 7 or whatever, just see if it works. All right. Hey, where does the GCF go?
Down.
Yeah, move it down. I mean, seriously, you want to get that point. Miss points elsewhere, but don't miss that point. And then we need to start seeing if we can factor this. So negative 5 times 15. Oh, man. It's negative what? Negative 75. Okay, that's not as bad as I thought. Does anyone see the ones I should go with? I'll tell you, the first one is 25. What do you think?
25 and 3.
Yeah, 25 times 3 is 75. Okay, and I didn't worry about the other factors. Which one has to be negative to get a negative 22? 25. Cool. There you go. All right, so let's look at this. I get 15x squared minus 25x plus 3x minus 5. Is that okay? What do I have in common with those two? 5? 5 and an x, right? That right? That's a 5x right there. Let's draw the little meter. 3x minus 5. I don't really have anything in common there, so I'm just going to have plus 1 as a placeholder. If it's a plus 1, none of the signs change. So I get the 2, and then 3x minus 5, and then 5x plus 1. There's my answer. What don't I miss? The greatest common factor. Yeah.
I don't understand why you wouldn't do negative 30.
Do what?
Find the greatest common factor of negative 30.
So our
I
30,
mean, not negative 30. Negative 30.
because I factored out the 2 first.
What two?
I had a greatest common factor of 2. 30, 44, and 10 are all even, so 2 factors in all of them.
Oh.
Then I bring that 2 down to the end,
Oh.
and I worry about what's in the parentheses now.
Okay.
So this is just coming down for the ride. We're ignoring it till the end.
Okay.
It's like the little brother you have to bring to the mall. You ignore him by the time you're like, oh, where's my brother? You gotta bring him home from the mall.
Next, if that was me, I was the little.
You were the little brother? Okay. It happens. Alright. Ooh, hey. This is back to some weird stuff. I think that is a 9x, and I apologize that my penmanship is horrible. So let me ask you this. Is 16 a perfect square?
Yes.
Yeah, that's 4 times 4, right? Is 9x squared a perfect square?
Yes.
3x times 3x is 9x squared, right? So this is the difference of 2 squares. So ready? 4 plus 3x and 4 plus 3x, done. So I figured out the perfect squares was by the difference of them. Okay. What about that second one? X squared plus 25x. 25 is a perfect square, right?
Yeah.
But it has an x attached to it. The plus sign means we're not dealing with difference. Difference means subtraction in math. So do I have a greatest common factor on this one, or can I factor down any further? What do I have in common between these two?
1.
An x. X plus 25, and that's as far as you can go. There's nothing more you can do. What about that third one? What do I have in common between them? There's a subtraction sign. So what should I factor out? What do I have in common here? X. You got to that point, you're getting 1 out of 3 points. How do you get your last 2 points?
Bring down.
Is x squared a perfect square? X times x is x squared, so is it a perfect square?
Yes.
25 perfect square? Is that the difference of 2 squares? So this is my GCF. So that comes down here. And if that's the difference of 2 squares, that should be x plus 5 and x minus 5. Done. That's it. That last one on the screen, 16x squared minus 25. Is 16x squared a perfect square? Yeah, because 4x times 4x is 16x. Agree? Is 25 perfect square?
Yeah.
5 times 5? Is that the difference of 2 squares then?
Yeah.
Yep. It's a subtraction problem between 2 squared perfect squares. So my answer is
4x plus 5.
4x plus 5 and?
4x minus 5.
There you go. 4x plus 5 and 4x minus 5. Done. So difference of 2 squares, 2 terms, subtraction sign. Both of them are perfect squares. How many more I got? Holy moly.
No.
All right. You ready for the gotcha question?
Gotcha.
Is x to the 4th a perfect square? Meaning it is x squared times x squared, x to the 4th.
Sure.
Yep. 81 perfect square?
Yeah.
9 times 9? This is the one you're not going to like me on. So you're going to get to this point saying, sweet, I'm totally done.
You're not.
Why not?
Because
What do you think?
You can do x and x, and then you can do 9, 3 and 3, right?
On which one?
that's you're doing the wrong.
First one or second one? So did I talk to you about the sum of two squares or the difference of two squares?
Because you're doing x.
Did I talk to you about the
X
sum
to
of
the
two
second
squares
power
or the
times
difference?
-9.
Did I talk to you about the sum of two squares or the difference of two squares? Difference. So what does this here factor to? What goes in there? X 3, 3. Done. Okay. Did I talk to you about sum of two squares? No. Does it exist? No. You can't factor sum of two squares. You can factor the difference of two squares. What about this one? Try that one. Uh-oh.
Same rule.
Same rule. Yeah, buddy. X squared plus 4, x squared minus 4. Think you're all done, and all of a sudden you minus 2 on the question. You're like, dude, how did I miss that? Well, you didn't recognize the difference of two squares happened one more time. What about that last one? 16x to the 4th, the perfect square? Yeah, 4x squared times 4x squared, 81. Here we go. Factor further? Yeah, that's the difference of two squares again. That's it. That's all it is. Huh. Uh-oh.
What?
You gotta come.
Dude, what did Mary say?
She's not
Dude, what'd she do?
Wait, hairband. Oh my.
What? What's wrong with your hairband?
It's my.
Oh.
It's plastic. Sorry,
I don't know, they don't tell me.
Oh man, that'd be more fun.
That would be what you did. Dude,
Class.
I literally didn't do anything. They don't tell me anything.
Yeah, they're pretty shaky.
One time Dory texted my mom, was like, "Where's Elizabeth? I'm gonna suspend her." And I was like in Miss Flatten's classroom, like doing homework.
It's kind of weird that Dean's texting my mom.
Well, he didn't text me. He emailed.
Get the lingo right because it's different context. Next is gonna be like, "Hey, Snapchat is my mom." What?
Like, just takes a picture of
Dory
it.
and
Where's your daughter?
I'm at lunch right now. That was a joke. That was a joke.
We gotta
I'm
go.
kidding.
I'm
Yeah,
at
we
6
do have to
period.
go.
Good luck. Elizabeth, as soon as you get out that door, just run. She won't catch you.
Yeah.
All right, almost done. Oh, shoot. Oh. Item 1. I have two terms up there. I kind of have perfect squares up there. Oh, this is just nasty. You know what? Let's just move off this one.
Is this not going to be on the quiz?
Nah. This one I want you to look at something. Let me highlight something that all three terms have in common. What do you think they all have in common?
X squared.
Why?
Why what?
Y squared.
Y squared.
I really just
Then I'm
said
left
X.
with this. Is that okay?
Sure.
Then you're like, okay, well, there's my GCF. That comes down as little brother.
Ready?
This factors, this actually is 7x plus 1. 7x plus 1 when it factors. I can only do so many that I lead through the long way before I start going cuckoo. All right, homework is page 39 and 40. Got it? Woo! Oh, yeah. Oh, almost had it.
Wait, can I say hi to your life?
You want to say hi to my wife? What?
Not mine.
Yeah, go ahead.
I do the same. Can I do the same?
Why don't we all do this?
Who do you want to say hi to?
Everyone, hi.
Hi, Clint.
No.
That's exactly why you did it.
You don't know what to do influence.